Yeah, so this is a follow up on the stream we're supposed to have the normal time today, but due to some factors beyond my control, we could not have that. But we couldn't have that stream, right? But we'll be having it now. So basically, we'll be looking at functions. So we are going. If you remember, we are going through the Rust by example book. So we are going from, and we already covered things like primitive, custom types, when variable bindings, expressions, of control or control flow. So we're currently on functions, right? Um, and so the goal is to complete everything here, right? So to complete everything, and then hopefully move on to something else, something more interesting. But I will not digress so far. So today we'll be looking at functions. We'll look at everything on functions from methods, closures, high order functions, and diverging functions, and try as much as possible to make it as explanatory as possible, um, so that you can truly understand the concept and then go on to you know maybe teach it to someone else, or use it in your upcoming projects and all that, right? So so once again, I would say welcome to today's stream. um yeah, sometimes life happens and things don't go as planned, but that doesn't mean that one um you know would would cancel on their plans. um one That doesn't mean that one will cancel on their plans because life simply happened, right? So I couldn't meet up to um I couldn't meet up to make that video this afternoon for so many reasons. But I hope that with this live stream, I'll be able to do justice to that. All right. So, once again, welcome, guys. So, we'll be talking about functions and closures in Rust. So, whether you're just starting out or you're looking to solidify your understanding, this session would break everything down step by step. We'll start with the basics of functions, then we'll move over into closures, and then we'll explore some advanced concepts like HOF, high order functions, and we'll go on to look at diverging functions and all that. So let's get started, right? So here I already created a file, imported that file into our lib.rs, made it a module and exposed it, that is, made it public, and I've imported it into the main function, right? So there's a function here. So yeah, so I've imported it here, and there's a hypothetical function. So in the previous stream that I was doing in the afternoon, there was a function I created called simple function. So in Rust, the way you can identify a function is by fn keyword. So wherever you see an fn keyword, you automatically know that that is a function. So I will just create a function. So first off, this function is going to be public. So we'll call it simple underscore fn. So it has to start with the fn keyword. So, and in here, I will just have my simple print line, and I would say hello world, right? So, going back into the menu, see that that error is gone because that function is now imported, right? You can see it's a public function from the function file, and so we're exposing that method. We made it public. So if I hold this and click, it takes me back to this place. As far VS Code, I think it's a VS Code functionality, right? File linking functionality. So I can, I'll clear this. Then I can just do cargo run. What's happening? Cargo run. And when I do that, I should get hello world. Exactly. So I get hello world. And so in actual sense, we've just created a function, right? We just created a function as simple as it looks. This is how we can create a function in Rust, right? So the next thing we're going to do is we're going to then go ahead and create more meaningful functions. I'm going to create more meaningful functions, and we're going to create two functions. So these functions are going to be parameterized. right? We're going to pass arguments to the function or parameters to the function. And at the end of the day, they will return a value. So we'll create two functions. And what we'll do here is we'll create, what I'll do here is I'll try to explain the explicit and implicit nature of returning values from a function. So our first function is going to be an add function that takes two arguments, so a and b, and it's going to return an I32 as their sum, right? So here I'll create a function. I'll call it fn, and I'll call it add. And this add function take a, which is an I32, and b, which is also an I32, right? So I32 are integers in Rust. So here we'll just do a plus b, right? Do a plus b, and yeah, there you have it. We have our function. So this function will take two arguments and it will do a calculation for us and it will automatically return it. Um, so something here is missing in this function, and that's what it will return. So in Rust, the way we in functions in Rust, the way we indicate what a function returns is by passing the value, that is the type, after the arrow key. So we pass an I32 there. So this signifies that this function is going to return an I32. And the function is going to return an I32. So the last line here, which is this, is basically like the last expression in the function would automatically, return a value, right? So we don't need to like use the return keyword, something like this, right? We don't need to explicitly return that, use that to automatically do the returning for us, right? So we can then go ahead and create like an explicit return. So let me say function, and I'll call this subtract, and it's basically going to be like the first guy. So I'll just copy everything here. The only difference is that subtract. This is subtract, not subtract. Now just paste this here. So it will still take A and B, but this time around we are going to do an explicit return, and we are going to change it from addition to multiplication. This is going to be explicit return. Exactly. This is an explicit return, so we can still use the return keyword here, but it's absolutely not necessary to do so. But then again, right, this is how we can we can use a function. So now what we'll do is we'll call these our functions in our simple fn function, that is a public function that we have access to outside of this file, and we'll be able to pass some certain values to this function, right? And then log something to the terminal. So first thing I'll do here is first off I'll delete this our hello world, and I'll pass an empty bracket here, and I would say add. So add is going to take two values. The first one is going to be, let's say you want to add 10 and want to add 20. Yeah, 10 and 20. The next we are going to use the subtract. So I'll just copy this. So today I'm not okay. So subtract. And here we want to subtract, let's say 40 from 20, right? So no more errors, no more error warnings. So I'll clear this and we'll run this code again. So if we run this code again, we should see some value. So we can see that here we added 10 and 20. So we have this. And the second one we subtracted 40 from 20 and we have this. So I can even go ahead to make it more explicit. So I'll say add. So this is for add. And this is for subtract. Save this and I'll run it again. First, I'll clear this and I'll run it. And yep. So now we have, for the adding part, we added 10 and 20, and here we are subtracting 20 from 40. So yeah, that's that, right, for the simplest of functions. So I would have a second part, so kind of like a part two. And the reason for this is just to really drill down into the concept of um, into the concept of of functions and try to use it to code something meaningful, right? So in the bid to do that, I would be looking at something called the FizzBuzz, right? The FizzBuzz algorithm. So we'll be looking at that, and we'll try to solve the FizzBuzz problem as quickly as possible. So I will really get the idea of how functions can be used. So what's FizzBuzz? So let's open another tab. It's a lead code fizz FizzBuzz FizzBuzz. So let's look at the FizzBuzz problem on lead code. So this is basically like lead code, right? And what is it showing me? Put it in Rust. All right. So there are so many ways in which we can do this, right? Here they are using like an implementation code, so we can always delete that and write our own stuff. But basically, and what a FizzBuzz is giving an integer n. So we want to return a string, right? So a string is like letters or a word, a string array answer. So of one indexed, where answer I is equals to FizzBuzz if I is divisible by 3 and 5, right? The situation whereby I is divisible by 3 and 5, we want to return the word FizzBuzz, and we want to return fizz if I is divisible by 3, or buzz if I is divisible by 5, right? If none of the above conditions are true, we just want to return I itself, right? So for instance, if the input is 3, we want to output 1, 2, and fizz, because we know that um, you know 3 cannot divide cannot divide 1, cannot divide 2, but can be divided by 3, right? So we'll basically check, do all these conditions, and at all points we'll keep printing until we have gotten to the size of this number, right? So I don't know if that actually makes sense. So the same thing is happening here too, right? So we pass 5 in, 5 so it's not actually divide, sorry guys, it's modulus, right? So what is modulus? So modulus is the remainder of 0. So when you divide two things and like the remainder is equals to 0, right? So modulus, modulus operator. So basically, the modulus operator is represented with the percentage sign, right? It's a mathematical operation that finds the remainder of one number divided by another number. It's also known as the remainder operator of integer, okay, remainder operator or integer remainder operator, right? So if, for example, 5 modulus 2 is 1, right? So 2 would go into 5 two times, remainder 1. So that's basically what it is. Sorry for the mix up that I had in my explanation. That was like a very, very funny mistake. But then again, that is how we are going to be solving this, right? We're going to be looking for the remainder. We're looking at the remainder when we do our division, right? So that's how they are able to do this FizzBuzz, whatever stuff here. So we'll be doing something similar to this. Although we're not going to be solving for exactly this, we can do this by storing our answers in a vector. If um, if we want it to run and pass on lead code, we'll write the code and store our answers in a vector, and then we can't even use a vector because the vector cannot take a we can't even use a vector for this solution, right? Because a vector cannot take um, integers or stuff. But then again, looking at this solution, right? Looking at this, what lead code is expecting, I think it will still work, right? Because the one here is actually a string slice, right? It's actually a string, or I'll just say a string slice because it is wrapped in double quotes, right? So it will still work, right? A vector will still work in this case. But then again, if we want the code that I'm going to write, if we want it to work in um, in lead code, would basically write our solution outside and bring it here and run it and see how it goes. But at the end of the day, it has to return something like this, which is going to be a vector, and then a vector of string slice or strings, right? Something like that. So this is not like the major focus of our live stream, but I just felt like I should show this question and you know really explain what I'm going to be solving for, right? I'll run the code here and we'll see everything, right, for what it is. So, guys, once again, welcome to this live stream. For those that are just joining, I was supposed to have this in the afternoon, but circumstances beyond my control. Um, didn't let me do what I was supposed to do. But then again, right here we are, and we are having it at this point in time. So, guys, if you have any question, please consider leaving a comment in the chat box. I would always appreciate that. I'm always willing to have like a conversation when I'm on these live streams. But for some reason, people don't want to leave comments, right? I don't know why. But please, you can always leave your comments, and I will do my very possible best to attend to them to the best of my ability. All right. So now let's go back to our code editor. So let's write a FizzBuzz algorithm, right? So I'll say FizzBuzz. So the purpose of this FizzBuzz is for me to really explain functions, and to the point that we really get what is happening, really understand how functions are being used. Of course, this live stream is not going to be enough for you to just master functions in Rust, but you get the point. It's basically like a summarized overview, an introduction into the concept, and just basically demystifying the whole thing, just to let you know that it's not that deep, right? It's not that complex as people would like to tag everything in Rust as complex and hard. It is not, to be honest. Anyways, let's start. So I'm going to make it very, practical, and and I'll use functions to solve this problem, right? So let's start by writing a very simple function to kind of like drill down the solve this FizzBuzz problem. So we'll start by, first off, we want to write a function to print the fizz, the buzz, or the FizzBuzz when we give it a number, right? So what we say is, first off, we want to say if it is divisible by, if a particular number is divisible by this, print this, right? Is divisible by this, print this. Is divisible, else if it's divisible by this, print this, right? So we want to basically say if 100 is divisible by 15, print FizzBuzz, right? If 100 is divisible by 3, print fizz. If 100 is divisible by 5, print buzz. Else, print the number if it is not divisible by 3, 5, or 15. Don't know if that makes sense. I don't know if that makes sense. But then again, right? So the first thing we'll do here is I'll create a function, and this function I will call it. This is going to be our FizzBuzz function, right? So I'll just take down this name, FizzBuzz, and this function is going to take one value. So it's going to take an integer type of, let me say u32. So I will just say u32, and here we are going to say if um is divisible. So is divisible. So this is a function that will take two parameters. So n, and the first one is 15, right? We want to, in this point, we want to print line, and we'll say FizzBuzz, right? So else, if is divisible by, if that value is divisible by 3, if the number is divisible by 3, so 1 3 here, we want to print fizz, right? So I'll copy this, paste it here, and I'll say fizz. So else, if is divisible by n is divisible by 5, so what I want to do is I want to print buzz, right? Else, I just want to print the number. So I want to print a number, and n itself, right? So this is the heart of our program, right? This is the heart of our program basically. So once again, this function will do the FizzBuzz printing for us, right? To do the FizzBuzz printing for us. Now let's go over, if you take a look at this hypothetical or unexisting, go ahead and create this guy, right? We'll create this is divisible function, and this particular function here that takes in two arguments, and we'll then use that to do our division, right? So we'll use it to do our division, or find the modulus, right? In this case, that's the right thing to say. We're looking for the modulus. So we'll create another function, and we'll call it is divisible. And is divisible here would take, so for the right hand side, which is the n, sorry, the left hand side, which is the n, so it will take a u32, and the right hand side take a u32, right? And we want to return a boolean. So we just need if it is a true or false. I remember what I said about what the function returns and how we specify it after the arrow keyword. So here we can just go ahead and say if, right, the right hand side, if arrow is hs, right, is equals to 0, right, we just want to do a quick return. So we'll do a quick return. Remember what I said about return, right? We want to return false, right? So we'll do it like an early return. Let me add an argument here. Let me a comment. So early return for division by 0. Right. Then this is where we'll do the actual where we'll do the actual um, you know the actual logic, right? So the expression that would actually return by itself. I remember what I said about um, automatic expression return from the last line. So using that idea, we will now come here and say if the left hand side modulus, so we're using modulus operator, the right hand side, right, if it is equals to 0, we just want to return. So at this point, we will just return true, because at this point we know that we don't need that. We don't need so remember, anytime in an expression, anytime we are returning, we don't need to pass semicolon, right? We just leave it like that. So it will automatically return for us. So we don't need to use like manually use the return here. Of course, we can still do like return, but it's not necessary, right? It will automatically return for us. So at this point, what is happening here is um, if the right hand side is equals to 0, we just want to do an early return. But in a situation whereby n, which is this n, this guy here, right? We've divided we've divided, used it to divide. Sorry, it has been divided by the left hand side, and the remainder is 0. We know that it is true, right? So um, we'll just return a boolean, right? Because it will automatically return true here. It will evaluate to true, right? So now that we've done this indivisible, we can already see that we're already having the LHS, which is the left hand side, which is already represented here for n. Down here, the same thing too for the right hand side for 15, 5, and 3, right? So the next thing we'll do now is we need to write a function that is going to iterate through um, a number and call the FizzBuzz and call this FizzBuzz, right, for us. Because take note, this FizzBuzz calls the indivisible, right? So we need to write an iterative function that will call the FizzBuzz for us. So let me even arrange this in accordingly. So I'll take this guy to the top. It doesn't matter how I arrange it, but just for for it to look like procedural and look as if we are stepping through the code step by step. I'll take it to the top. Then down here, I would write a function that is going to, if not a function, yeah, a function that is going to loop through, like use a for loop to loop, through our number and call the FizzBuzz, passing the number, which is going to be an index, is going to be I, into the FizzBuzz. And remember that our FizzBuzz takes only one argument, right, which is an integer of u32. So if you remember when we did something about flow controls, right? I think we did something about um, flow controls where we talked about the for talked about the for. So this is what we'll be using here, this guy, right? So we'll iterate over, specifically, we'll be using this guy, right? So we'll use it to iterate over a number that will be passing into our FizzBuzz, right? So we'll create a function and we'll call that function somewhere, passing the number to it. Then we'll iterate each of the number that we passed, right? And when we iterate each of this number, we'll then, as we are doing the iteration, we are passing it into the FizzBuzz, and the FizzBuzz is now going to, do our calculations for us and then print something to the terminal. So enough of the explanation. Let me just go ahead and write the code. So we have Fn and we'll call it FizzBuzz 2. And like I said, this is going to take a value. So it's n, and it's going to be type of u32. And this value, and here we'll now do our for loop. So it's not a for in. So Rust does not have for in like other languages. In is just a keyword on its own, right? So you can also research on that. So we'll say for I in, because we want to, for I in 1, full stop, inclusive of the last number of the number itself. So we want to loop through the number itself, right? So we'll pass n here. And so in there, in that our loop, so what is happening here, we are saying we want to move from, so if we are passing 5 here, we want to count from 1, 2, 3, 4, 5, right? We want to count from 1, 2, 3, 4, 5, 5 included. That's why we have the equal sign here, right? So here I will then call this function the FizzBuzz. Remember, it takes one argument of a u32. So I will just call the FizzBuzz, say FizzBuzz, and I would pass in my I. So I need to pass I, this I that I'm iterating. So I'll pass I there. And that's basically everything, right? So with this, we've implemented a FizzBuzz. Cannot find n in the scope, blah, blah, blah. Okay, we'll get to that. So now, yeah. So the next thing we'll do is we'll then go ahead and pass and call this our FizzBuzz in our simple function, because remember, this guy, I'll take him down, is the function that is exposed to the main. And remember that the main is the entry point for our application, right? So this is where I will now call the FizzBuzz 2. FizzBuzz 2. And in here I will just pass, let's start with 10. Let's start with 10 and see how it goes. local variable similar. Oh, sorry about that. I'm using, instead of using n, I'm using u. So I'll change that, and that should solve all our problems. Exactly. So now we passed 10 here. So I'll just go ahead and I'll zoom in a little bit, and let's run that code. So I'll clear this MF, and here I will then go run. Okay. So you can already have one. So 10 cannot be. So the first value, okay, we have one, we have two, we have fees, right? What's happening? We have fees, we have four, we have buzz, so six. So this will be five. Um, then fees, which is for a situation whereby, so basically what is happening here is this, right? Um, one, we'll go through the value. So we have one, two, at three, right? Three can be divided by this side, by this block of our code. So we would print fees. So that's why we have fees here. Where we're supposed to have three, we have fees, right? So what I can do is, in order to make this more explanatory and interesting, I can just somehow tweak our function to show the values that are being, that we have a modulus for, right? So when we do the division, where we don't have like a remainder, right? I can do that. So let me just do that. So here I would add this, and I would say n. Let me just add, yeah, n. So n is the value. Same thing here. So I want to see the values that are being divisible. So that's n here. Same thing for balls. And I'll say n, right? So here I will just comment out these two guys. We're not using them again. And I'll save, and I think I should just use, okay, print line is good, right? Print line is good. So here I would go ahead and clear it and run this code again. So when we run the code, you can then automatically see that when we iterate through the value we passed here, because we passed 10, so when we iterate through this 10, right, what we are basically doing is we are saying we are going from 1 to, so I'll add like a comment here. So we are going from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So at each point, we are doing a calculation, right? We are doing a calculation. And at each point in that our calculation, what we are doing is we are checking, is 1 divisible by 15? If it is not, we check if it is divisible by 3, right? Sorry, if after dividing we have like a remainder of 0, right? We do the same check for 5. And at the end of the day, if it is not possible, we'll just go ahead and print 1. So that's why we have 1 here. We do the same thing too for 2. So I'll copy this guy here because I need it at the top. I'll paste it under here, on here, right? So I don't need this side. And I'll close this a little. So the next iteration, so the next cycle of this code running, will then go over to 2. So when we go over to 2, 2 now is I. So we are passing I into the FizzBuzz, and we are getting it here. And then we are passing it into this if condition, right? So here we are then doing our conditional check. So n now is now 2, right? We check the modulus of that. We see that it has a remainder. So it would, I think 2 will go into 15 7 times and it will remain 1, right? And we check it for this. It will go, 2 will go into 3 once and it will remain 1. 2 will go into 5 2 times and it will remain 1. So none of these cases is true. So we'll just go ahead and print 2, right? Then we get to the third part, which is fizz, and which is 3 that I just printed by the side. Would iterate to the next point, which is 3. And when we do that, we pass I becomes 3. We pass it into the FizzBuzz. We get it here. We pass it into this our conditional, this our, sorry, if block. When we do that, At the first point, it's 3, right? So we'll do the condition. So we'll check. When we check how many times 15 goes into 3 goes into 15, so we know that 3 plus 3 is 6, plus another 3 is 9, plus another 3 is 12. Can you guys hear me? Oh my god, I don't know what's happening today. I've been having a lot of um internet lag today. I don't know what's happening, but then again, um so we'll do that check and we'll see that would have the fees part, right? Which will run and give us 3. We also do that, we'll get to 4, we do that, we'll have a remainder, then we'll run the next line of code, and we do for buzz. So basically we are just moving over this number that we passed in here, right? This 10. So we are passing 10 into the FizzBuzz, and in this FizzBuzz, we are iterating over the value, the 10, to be able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we are using that thing to do like a check here and offloading our modulus check to is divisible function, which is this guy, to handle. So you can already see how we break the code into minor little functions that can be easily reusable, right? So I can absolutely go crazy with this and decide to pass like 100 to this, right? And to do the calculation for us. So I would can go run. So you can already see it already did that calculation for us. So I'll just try and open this. Oh, it's a whole lot, a whole lot. In fact, I don't think. Okay, yeah. So you can see it starts from 1, 2. So where we print 3, that is for fees. I also printed the number by the side. So we have 4, buzz for 5, fees for 6. We have 7 that has a remainder, 8 has a remainder, 9 does not have a remainder, so we printed fees. Buzz 10 does not have a remainder, so we printed 10. And printed buzz, sorry. Then we go to 11. For the next one is fees, which is for 12, 13, 14. So we did that all the way down till we got to 100, right? So this is just a very simple algorithm question. If we wanted to pass on lead code, we'd figure out a way to a vector and make sure that is of string type, right? Probably we'll convert whatever it is that we are printing, right? So basically, if we want to achieve this, I can go ahead to do this, right? I can actually just initiate or create like a new vector using the vec macro, right? And just basically push those values into the vector, but at each point we'll convert it to a string, right? We can do that. And if we do that and we pick this code and run it here, it will pass, right? But that is something that you can do in your own free time if that interests you. So let's move on because we have a lot to cover, and there is no don't have enough time on our side. So next, I'm going to talk about closures, right? So closures, these are basically closures, right? In one of my previous streams, I talked about how closures are similar to arrow functions in JavaScript, right? So arrow fn versus closures in Rust, arrow fn in JS. So I have this AI something that I have on my browser. I don't know if the rest of you guys have it. It just gives me like a very simple summary of. So it's basically just a search lab, an AI overview of what it is I'm trying to, um, you know, research on or search on. So it says here that in programming, why both arrow functions in JavaScript and closures in Rust are ways to create anonymous functions that can capture variables from their surrounding scope. The key difference is that in the Rust closure concept, in Rust, the closure concept is more explicit and is a core language feature. While in JavaScript, we know yeah, it's a syntactic sugar, we know all that. But at the end of the day, right, it's still the same thing. Right? It's the same thing. Let's forget about which one is powerful or which one is not powerful. I get it that okay, fine. that of Rust is more powerful and is native to the language, blah blah blah. Why the arrow function is more of like a syntactic sugar and stuff. But at the end of the day, right, the whole idea, the basic idea behind both of them is the same thing, right? So you have function, something like this is an arrow function in JavaScript, and this is closures in Rust. So they are similar. So the reason I'm bringing up this is because if you're coming from a JavaScript background, you can easily relate with these things, right? You can easily um, use that same knowledge that you're coming to the language with to kind of like understand, you know, what I'm going to be talking about next, right? So let's just get back into it. Basically, closures are like functions, but they are environment. And so let's look at a simple example. So in our simple function that we're exporting, here I would say let x be equal to 4, and I would say let square, because I want to look for the square. So the square of that x, I would say I'll use my closure. So I'll say something like z, and here I will now say z multiplied by x. Sorry, not z, x. What am I doing? All right. So yeah, so we have this, right? So in this case, x is captured from um, you know, our environment, right? So now let me just go ahead and print a print line. I'll say print line, and I'll say square root of 2. I'm looking for the square root, so I'll say square. And here I will then call this function. So I'll call this function, because remember this is a closure is a function, right? So I'll call it here. So I'll just say square, and in there I'll pass 2 because I'm looking for the square root of 2, right? So it's going to take that and do the multiplication. So z in this case is going to be 2, right? So if you want to take note, if you want to, if so to prove this that this z is to, remember I said in my previous streams, I said every integer in Rust has a default value of I32, right? But we can explicitly change it. We can add a suffix at the back of this 2 to make it like an I8, right? And if I do that, you would see that on line 43, this thing that we have here as I32 would automatically change. What is returned here, right? If you look at, there is an arrow here and there is I32 that is being returned. Remember what I said about what we return from functions. So after the arrow, the next thing is what we return. So we specify what this function is returning, and it's an I32. The same thing we did here, that this our indivisible returns a boolean, so it returns a true or false, right? So now here, my Rust analyzer is automatically telling you or telling me that this function is going to return an I32, right? But I can change it just to prove to you that Z here is coming from square where I passed it in, while X is captured from my environment, right? Why X is captured from my environment. So now I'll just go here and explicitly append to I will explicitly append to the that is to 2 that I passed into square. So I will say this should be an I8. And let's see. So you can automatically see that it has changed, right? That value has changed to an I8. So the purpose of doing this thing is because I'm trying my possible best to really explain these things so that you understand how code is moving, how the data, right, or how arguments are being passed, right? The ordering of these things doesn't really matter in some sense, in some cases, but it's very important for you to understand how arguments are being passed. So this Z here and the Z you're seeing here is a representative of what I am passing into this square, which is, you know, this arrow, I'm sorry, not arrow function, this closure, right? And X here is being captured from here, right? From the environment, right? So I will just undo that and leave it as the default. So I'll just leave it at I32, and I'll save this, and I'll comment out this guy because we're no longer using him, right? So when I do that, let me run the code, right? So if I run this code out, we should get 8. We should have 8 as our answer. Right, so I'll clear first. I'll do cargo run. So you can see, right? So square of 2 is 8. So you can see, so what's happened here is 2 times 4, which is this, is 8. So automatic. So what happened here is that the closure, the closure that is square. Square is our closure here, right? Square is our closure. So this is our closure, but we gave it, we equated it to this variable square, right? So our closure here captured x from its environment, right? So this is its environment. So it was able to capture x here because, of course, we declared it here, right? So it captured x from its environment. So closures are are super flexible, and they can infer their inputs and return types, just like we saw here. So this thing you're seeing here, where you have implement function i32, which is returning an i32. So what it's doing here is it has done like a type inference and also inferred its return type. So we don't always have to do like a manual annotation or explicitly, do this stuff that we are seeing here, right? We don't have to do that all the time. So let's look at another example. So we'll try to rewrite our add function. This function, we'll try to rewrite it using closures, right? We'll try to rewrite it using closures. So here, um, so what we do now would say, let's add be equals to. So we want to create a closure that takes into two parameters, right? So we say a comma b, and in there we then want to do like our calculation. So we say a plus b, and we'll end this with this. So for now, it will be implemented function is unknown and the return type is unknown. That's fine. That's okay. So now we'll then do our print. Go ahead and this. I'll copy this guy because I'm feeling incredibly lazy today. And here I will just call this a sum. So I'll say sum, and here I'll change this to add. I'll call this add, and here I want to add 2 and 3. So it's that simple, right? So I'll run this code again. So I'll clear first, then I'll run. So I should have 5 as my answer. So you can see that we have the sum here, right? So you can see how we just immediately did what we did here in one very simple line of code, right? This is just a very, like, I even prefer this, right? It's very, in my opinion, is quite easy to reason about, very easy to follow, and it's something like I can just do this in one line, right? It's just like writing arrow functions in JavaScript, very easy to do. So um like I said, function closures are really hard. You can really drill deep into them, but you can pass them into other methods and stuff, right? So we'll get to that. So one thing to take note of is that closures can capture variables in 3 ways, right? They can capture variables by reference, they can capture variables by mutable reference, and they can also capture the value itself. So by reference is when we use the ampersand, and when we use the ampersand, and by mutation or by mutable reference when we use the reference and make them mutable, and by values when we do things like cloning, right? Overall cloning of that very value. So I'll just add like a comment for that, um, so that in case you come back to this video, you'll be able to. I'll just paste this here and comment it out. So basically, this is how closures can capture variables in 3 ways. So by first is by reference, second is by mutable reference. So the and mute keyword, and the t represents the value, right? Why by value is when we do things like clone, right? So let's look at let's look at an example. Let's look at an example. So first here, when we want to capture by reference, would say let's use something like a color, right? And we want to print you know a color to our terminal or something. Trying to think of how we can do this kind of thing. So I'll say let's print color. So print color is going to So we'll just say print line, and it's going to take color, and we'll just pass the color here, right? So at the top somewhere here, so let's just create a color here. So we'll say let's color. So this color is going to be a string, but we are going to put it in the heap, right? So string dot from. So anything we put in dot from is we are placing it on the heap. So we'll say it's green. Green. So you're going to be a green guy. Okay. Save this. Expected item found. Let full list of items. Not understand why that is an issue. String from print color. Oh, sorry, I'm doing this outside of my function. Oh, I've said this. So I'll put it in here. Put it in here. So I should not have that error again. Yeah, silly mistake from me. All right, so I'll just do cargo FMT. So cargo formats to format code. So everything looks nice and sweet. So so first we've added a string on the heap. So string.from. So this is a string, and we are passing that string to this list. So this is by reference, right? So we're referencing um, our color here. So if I go ahead and call, because of course, we can call the print color is a function, right? So I will just do print color. I'll call it here. I should be able to see green when I run my code. So I'll comment out these guys, and then here I'll just go ahead and oh my god, already screaming. Let me just leave them in. It's not taking any space. So I'll cargo run, and I should get green printed. So you can see, right? So this is by reference. So we just did this by reference. I'll go ahead and show how we can also capture a value by mutable reference, right? How we can do that. So how are we going to do this? Let's use something like a count. We'll use a count. So we say let's remember I said mute, right? The mute keyword, and we set a count of the value to 0, right? Then here we'll just do our let. So say let's the mute increment. So mute and increment. So and it is going to, of course, our closure. Put it in the bracket, and in this place is where we'll do our increment, right? So say count is going to be plus or equals to 1, so we are incrementing it at that point, and we'll print, right? So we'll print the count. So print line, and we'll say count. So we just want to print that and add a yeah. So because this is an expression, right? So we want this expression to return. So everything from here is going to return to this increment, right? So it's this increment that we are going to call. We're going to call it in order to get that value. So I'll say increments. Increments, I'm going to call it, let's call it like 3 times, right? So that's would see what we got. Okay, save. And each one we're going to end it with semicolon, semicolon, and semicolon. So go FNT. What happened here? What is happening here? Print line. Oh, I don't have my. So I need an exclamation mark here because that's a macro. Exactly. So cargo FMT and cargo run. What's happening? Print line. Oh, I need to. Okay. So you can automatically see how the compiler is like guiding me with useful error message. And this is what I always talk about about Rust, right? It's so explanatory when it comes to all these things. Like the compiler will help you so much. So I'll just do cargo FMT and I get my code formatted. Then I'll run the whole code again. I'll run. um, So you can see we have count 1, 2, and 3, right? But the point here is that this is by mutable reference, right? So we captured the value by mutable reference. So the first one was by reference. The second one was by mutable reference, and the last one we'll now talk about is by um, you know um, by value itself, right? So in this case, we're using something like the move keyword and all that. So, and I'll explain what this move keyword does, right? Because it's going to like, so let's go back to this and say move in Rust, right? So move in Rust. So it will take ownership of whatever it is, right? So let's look at what move does. How move works in Rust. This is a better place to be. So this is say it might sound like a dumb question. I couldn't find good articles about move in Rust, although found many articles about move and ownership relationship. My question are that can I move copyable variables, and does move shallow copy the variable objects? Probably not. Blah blah blah. Deep copy, probably not. Okay, deep copy or something else since Rust is passed by value language. Blah blah blah. Okay. Rust includes shallow copy indeed. I don't like this answer. Thank you for the solution. No. We can't use this. Um, hmm. Okay, let's look at this first guy here. So it says move converts any variable captured by reference or mutable reference to a variable captured by value. Right. So still back to everything that we're saying here. Captured by value. That's it, captured by value. Right. So goes ahead to say, okay, let's say there's a vector here. So they created a vector using the vector macro, and this is exactly what we are going to be doing. Funny enough, this is exactly what I wanted to do, right? But we're going to be doing it for our green here, for this green, the color here, like the green, right? It's funny. So data will no longer be available. It is now owned by closure, right? So if I guess if I do this, there will be like a compile error. I don't really know until we run the code, right? Yeah. So, thank you for that comment. Language, to be honest. Um, Thanks, Sheriff. So, as I was saying, we are going to. I think Sheriff's comment has swayed me off my feet a little bit. Anyways, show it again. As I was saying, we're available, right? So we have that, and would know if it would have a compile error after using move. I believe it would have a compile error because the value is no longer available. It is now owned by a different guy, right? So it's no longer available to data. It's now owned by closure. So the same thing is going to be happening here. When we move color, it's no longer going to be owned by color. It's now going to be owned by whatever variable that we declared here. So let's just do that. So we say let's consume. So I'm writing leads. Let's consume. So this consume, and I'm going to say before our this thing we say move, and here would now print line, right? So say consumed, and we just pass our color, right? So say color. So so yeah, what would happen is when we it should break, right? It should break, not here, but if we try to call print color again after we've called consume, right? After we've called consume. So let's do this. So we'll say consume and then save this and let's run this code and see what happens. All right, so we have consumed green, but now see what happens when I call color here, print color. So I call print color here again, and I run this code. So you can see that can't move out of color because it is borrowed, right? So we borrowed it to move. So let's just run. So I will see like a more elaborate error message. So could not compile exactly like I said. We will not be able to compile it because we moved it from where it belonged, right? So we cannot do that in Rust, right? So the same borrow letter used here, like we've borrowed it and now we're not using it here, right? So this is like one of the things to note. So looking at the error message, which I love so much, I like to drill down into these things. You can already see that we have this error saying cannot move out of color because it is borrowed, right? We borrowed it from color. Yeah, it now belongs to consume, right? So here it goes ahead to say on line 52, we had print color, which was a borrow by a consume by reference, a capture by reference, I mean. So we used it here. So we borrowed a borrow occurs due to its use in closures, right? So that borrow happened. So borrow of color occurs here. Then move out of color. So since we used move here, right? We then moved it out of where we had declared that variable. As we now moved it into this guy. So move occurs here due to use in closure. So we specifically moved it here, right? So then we are not coming again here to borrow. So we are trying to like use it here after it has been moved, right? Basically. So borrow letter used here. So the place where we borrowed it, we're not trying to use it here. So in that case, it is going to break. And that is exactly what is happening here. Right. So it all boils down to the ownership and borrowing in Rust as a language, right? When you understand how ownership and borrowing works in Rust, um, this whole thing will begin to make a lot of sense, right? To make a lot of sense. This particular book does not cover ownership and borrowing, but if you want to really go deep into that, so the Rust book, you can. So there's the Rust book. There's the Rust book documentation. You can search for this. So there is this guy. Where is it? So this is understanding ownership, right? So under this place, you would really understand a lot of things about the ownership system of Rust, how it uses something called resource allocation is not initialization, RAII, to handle previously a theoretical concept that was later built into the language, right? Then you go into things like referencing and borrowing. So this is where you really um, you know see most of these concepts that I'm talking about, right? Then you have the slice type, so many things here, right? You can geek away with this. It has a lot of theories, right? But I prefer Roster example. But make no mistake, this book is an absolutely amazing book to read, right? If you love going deep into theoretical aspect of things, this book is for you, believe me. So I said something about resource allocation is initialization. Yeah, so that's the thing, but that's a completely different subject altogether. So I'm not even going to be going deep into explaining what that is. So let's just continue. But then again, if you really want to understand ownership, right, use the Rust book. So the Rust book, this is like, the god of everything Rust learning, right? So back to this place, so basically we just showed how the whole capture stuff works and um, how we can do that using closures, right? Like I said, closures can capture variables in three ways: by reference, right? By mutable references, and by value. And in that case, we use the move keyword. All right. So closures can also be passed as arguments, right? So the entire reason or the entire um, point of even using closures in the first place is because um, we can pass them as closures, right? We can pass them as closures, and we can not pass them as closures. We can pass them as to other certificates for us to do this, right? So I'm just going to add a comment to that. So I'll add that here and just comment it out. Save and go FnMut. So Rust Closures can be passed as argument to functions. Ross provides three traits for this. So we have the Fn, which is captured by reference. We have the FnMut, which is captured by mutable reference, and the FnOnce, which is captured by value. Right. So it's still like similar to how closures now capture values, right? How they capture variables from their environment. So it still uses that same ideology for when we are passing them as arguments to other functions, right? So let's look at an example. Let's look at an example. So here we are going to say we are going to say so here we are going to say that let's try to um, you know try to show an example of how this works. Though I'll not be really going deep into it. Um, so basically, would create variables, right? So we say the first one we say let's um do something like greetings. So it's very difficult to come up with variables distance. So this is going to be a slice, yeah, a string slice, and we're going to create another one. So let's farewell. Um, farewell equals to let's get another string slice. We'll say goodbye, bye. So this is going to be hello. The next one's going to be goodbye, and we then say we use something called to own, right? Uh, okay. So what does to own do for us? So creates own data from borrowed data, right? Usually by cloning, right? So um, okay, all right. So would let's show how we'll do this, right? So the first thing we'll do is let's create a function. So we'll create a function called apply. So fn apply. So this function to take f, let's just call f as a generic, and here say f. So where f is fn, we want to return f. So f is, so we have all these things here. You can see FnMut and all FnOnce. So we can say where f is fn. So we just want to call the function, right? Return automatically. All right. So down here, say so we use our closures here, right? So let's diary. So we'll do two things in here. So the first one is we are going to capture the greeting by reference, right? So we say print line, and I'll just say I said greeting, right? So I'll pass my greetings here. So this is a capture that is capture greeting. So we're capturing greeting. Where is that stuff again? Capturing greeting by reference. Right, so we're capturing this greetings. Is it greeting or greetings? Capturing greeting. Yeah, capturing greeting by reference. I'll put my exclamation mark here to take away that error. And we'll do the same thing for the so we'll do something similar, but this time around we are capturing it by value, right? So the next line is going to be print line. So we're going to print line. In that print line, we'll then say then I let's just shouted or screamed whatever like I said. So I'll pass my farewell here. Farewell and it's this save just happened. Save. Okay. So I have this and I would end it with semicolon. Then I want to call the apply, right? So I'll call my apply function and pass diary into it. So that would then call our closure, right? So I would apply and pass diary to this guy. And yeah, so what I've shown here is a capture by reference and a capture by value. So here we're capturing. So let's say capture farewell by value. The other one was capturing by reference. So here, what the apply does, apply takes a closure that implements the FN traits. Right? So we're implementing the FN traits here. The closure captures greeting by reference and farewell by value. Right? So we're capturing this by reference. It does not matter if it is a mutable reference or whatever. Right? Same would still work. So if we added a mute here, still work. Variable does not need to implement. Yeah. Okay. On default, yeah, it doesn't. Immutable. Okay. All right. So I think that was like an oversight for me. But basically, we're capturing by reference here, and we're capturing by farewell. I will look for an example. I'll research on an example of how we can capture by mutable reference. That is this one, right? Mutable references. So then, I would go ahead and run this. So I go run, and I should have. I said hello, and then I screamed goodbye, right? So you might be wondering what to own does. So let's just look at it. I always like looking at this guy. So to own in Rust, what does it do? So it's a trait, right? A borrow on the STD borrow. So basically, it says um, a generalization of clone to borrow data. Some type make it possible to go from borrowed to owned, usually by implementing the clone traits. By clone, but clone only works only for going from a reference to a value, right? So the to own trait generalize clone to construct own data from any borrow of a given type, right? So basically, we have something like this. So this is like the basic usage. So we have a string slice A, and we want to own it. So we can say we put it in this variable s, and we are saying s to owned, and we're passing it to ss, right? So ss now becomes the real owner of the value. So it goes on and on and on to show other. So there's also clone into, right? So there are a lot of theories behind this, right? With different use cases for it. But yeah. So next we're going to talk about higher order functions. So we're gradually coming to the end of this. Um, so higher order functions back here. So um, yeah. So basically, higher order functions is a function that takes another function and produces a more useful one, right? So HOF. If you're coming from like a JavaScript background, you must have heard about something like HOCs, like right, higher order components. Similar concepts. The same thing is happening, right? They are both cousins in this case. Well, I say distant relatives because Rust is a different language from JavaScript, right? But Rust also supports high order functions, which are functions that takes other functions as arguments and return them, right? And this is very, very simplified, right? Very, 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 very simplified, right? Very simplified. So let's look at an example for this. So now, going back to the code, so I'll call this higher order functions. For this other one, we just did closures as input parameters. So we just pass that instead of commenting it out. So I'm adding comments here. Closures as input parameters. Then we have capturing variables. I'm just trying to add all the comments that we need. So this is where we are doing everything for capturing variables and where we talked about closures. This is our place talked about closures. So it's very important to add comments, which is something I did not do. So this, save, and that should be FizzBuzz. We added comments or this guy's FizzBuzz. Okay, so save this and let's continue, right? So the next thing we're going to talk about is higher order functions, right? Like I said, these guys are, they're functions that take other functions as arguments and return them, right? So what we're going to be doing here, um, we're going to be writing a function. And this function is going to take closures, it's going to take numbers, do some things, you're going to map the numbers, get the square of these numbers. We are going to take numbers that are less than 1000, right? Because we're going to be using 1000 to do the mapping, and we're going to pass in 1000 as a value because, why not? We are going to filter out the odd numbers. We're going to write in a function to filter out the odd numbers. At the end of the day, we will now sum it up, right? So, basically, I'm going to show like a functional approach to solving problems using like map, take a while, filter methods, which are all method. All these methods, right, are all high order functions, because they can take closures as arguments, right? So we'll do that. They can even take functions externally defined, like functions as arguments. Right? So the first thing I would do is um I would say here let's sum, let it be, let's say u32 and it equals to, let's say we want to do range. So the range 1000, right? So this wants to do that. So we'll say dot map. So we want to map, right? So mapping now it will take a closure. Right? It's already even suggesting like there's a lot of ways you can see it here, right? So a iterating over this dot map, so it takes a closure. So in this case, it's going to take a closure, right? And we'll just use n because I like n so much. So I would say n. So that n is an I32. So we'll say n times multiplying them by themselves, right? N. Exactly. So this is it basically, right? So let me just run this first part. Can I? Yeah, I should be able to do that. Mismatched type using a U32 found struct blah 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 was saying. Okay, that's funny. Um, this is a range like I mentioned. So let me just run this code and see the error that I'm gonna get. This is going to be more explanatory. Um, okay, so I'll just take this out first and allow implicit to happen here. So it should. Oh, okay. I got it. Okay. So it's implements the iterator traits and it's an item of I32. Oh, okay, for this range. Oh, I see. I see. Okay, that makes a lot of sense. Yeah. Okay, so let's just run this and see what happens, right? Let's run this. So clear. And I'll run this cargo run. Oh, I should not expect to see anything because after all, I'm not printing anything. So I'll print line. I always make that mistake. And I'll call it sum. Some use a lot of that and here I'll just pass sum, right? That should work. Okay. Does not implement the. Oh, I see. So I need to use one of those weird question marks and okay, do this and let's see what happens. The error has somehow disappeared. So now run this and let's see what we get. Hmm. Okay, it's printing everything in this place. I was hoping that it does a a print for me, right? But one thing I can do is I can end it. Okay, to do the sum, right? So I'll just say let me use sum and do something like this and see what happens. Uh, Elements. Okay. The following implement traits a duration implements. Okay. Duration some a lot of errors. A lot of errors. Okay. So um let me give it that type of view. 32. See what happens. Okay. Run this. Go around and let's see what happens. Hmm. So um this is what I get, right? So this is like the sum, right? Um, of everything that was done in the map and called the sum on it. But this is like not the scope of what I'm trying to do. I'm just like playing around here. But basically, let's go back, right? So first we have the map. The next thing we'll do is we spoke about take a while, right? So take a while, we are going to use it to pass the reference of n, right, which is what we've mapped, and we are going to take numbers, certain numbers, right? We're going to take all the numbers that are below 1,000, right? So I would say dot take while. So take while. So here we still pass that same right closure, right? So closures are functions, so we pass that same closure. So use the ampersand because we want a reference to that n, and we want if the n is less than 1k, right? And next we want to filter. So we want to do like a filter. So filter is also a higher order function because it can also take like a closure. So we want to also pass a reference to n. Because remember, at every stage, right, when we do the take a while stuff, when we do map, we are modifying n, right? When we do like take while, we are also modifying n. Now we are filtering, we're also modifying n, right? So n is ever evolving at this point. So here we want to take like reference. So we don't want to completely take like we're using the reference. So here is going to also be this, and um, so this is where we are now going to call an external. So just to show that we can also pass an external function into higher order functions, not only closures. As we are going to create this particular one, we are going to create another function, and this function is going to return a boolean for us, and it's just basically going to check if the remainder of a number is equals to 1. So if that is the case, we'll just return true, right? So I'll call this function is odd. So if the number is odd, I want to return so n here. Into this is odd. So the is odd function somewhere here. So let's create odd. And this is odd is remember n, we're expecting n, which is a type of a U32, and we're expecting it to return a boolean divided by 2 is to 1. If that be the case, what is happening? Mismatch type U32. Why am I getting U32? Why am I getting mismatch type? Hmm. Is it U or N? What's the issue here? Construct. Let me see. So this is implementing the iterator. This is implementing iterator. Okay. So next, then I'm now going to do my sum here. So let's see what happens. All right. So I needed to wrap up my sum. So basically, what we are doing here, right? I'll add a comment for each of this. So what's where we are. So this is our range, right? So this thing here, the range is similar to what we did here, similar to what we did in where is our FizzBuzz problem? Similar to what we did here, right? Similar to this, similar to that. So yeah, so this is like our range. Then would here we are squaring each numbers, right? So I'll add a comment here. Say square each numbers, right? So next, the next thing we are doing, we are taking numbers that are below 1,000, right? So take numbers below 1,000, and next do this. So next we are going to add the odd number out. So we're going to filter odd filter odd numbers, right? So filter odd numbers. Then finally we are going to sum them up. So sum up everything. Exactly. So this is what basically is happening here, right? So at the end of the day, we'll then go ahead and print sum. Right, so we'll run this and I go run. And you can see, so we have 5, 4, 5, 6. Right. So this is like a really functional approach to solving problems, right? So we have the map, we have take while, filter methods. All these are all high order functions, right? Because they take closures as arguments, right? And we have also seen that they can also take like a function, like they take closures as arguments. Right? You can also pass a function. We can be very flexible with this, right? And you can see how it tells us to do a whole lot of things in just this line. You can make this like a single straight line of code, right? Instead of the way we did it. But at the end of the day, if you really deconstruct what is happening here, it's just closures being passed into higher order functions that are provided to us by the Rust language. Right. All right. So last but not least, we're talking about diverging functions. So diverging functions are functions that like they will run forever, right? So if you've done anything that has to do with embedded systems, like writing code for hardware, which I've played around with, I'm currently playing around with. Um, we see this kind of functions there, right? So let's just do some googling. Let's ask Google. Diverging is in Rust used in embedded code. Let's see what it says. Hmm, I've not seen anything here. Why would I use divergent functions? Okay, let's read what this person says. Rust has processing syntax. Um, I don't know why. Okay, saying what cost divergent function. Blah blah. It says panic cost current thread. Okay, so it says it has several uses. It can be used for functions which are designed to panic or exit the program itself. Um, okay. It's one such function, but it can also be applied to functions which wrap panic, such as printing out more detailed error information. It can also be used for functions that return if a function goes out into an infinite loop, such as the main loop of the server, and thus never returns. It could be defined this way. Another possible use would be a wrapper around the Unix execute family of functions in which the current process is replaced with the one being executed. It is useful to have such a type because it is compatible with all other types. In other words, in order to be type safe, Rust has to ensure that all branches of match or if statements return the same type. And so there are a lot of use cases, a lot of use cases. And there's even an update on the RFC for this, and then so many use cases. But um, basically, divergent functions are useful for infinite loops or functions that terminate a program, right? So that's like the basic summary of everything. Functions that are that so in embedded systems, right? A diverging function would be a function that runs forever because in embedded system, you don't want to return anything, right? The program just has to keep running. The moment the device comes up, it continues running, right? So this is something that I would also personally make my own research on, but I believe that should be the case. I believe, right? So you can also look into diverging functions. No much and no much low like entry level application into what you basically want to use diverging functions for. So yeah, that's why I'm not really going to be going detailed into, but I'm going to show you what I'm going to be showing what they are, right? So for instance, let's write a function that never returns, right? So we'd call this function panic. So say fn panic, right? So this guy never returns, and how we indicate it is that he returns an exclamation mark, right? So we'll just write a print line here. So print line, and we say this guy never returns. He runs forever. All right. So now this is oh, what am I getting here? Expected mismatch type found unit type. Wait, mismatch type expected this found type. Why is this breaking? We have panic. Okay, so let me just cut this guy out and let me place him under here. See what happens. Mismatch type expected type found unit type. Okay, so I guess I'll just make this a public function, right? Make this a public function so I can call him outside of this place. Okay. Um, Divergent functions. Okay. Um, use the panic keyword. Sorry about that. Okay. All right. I think it's because I used print instead of panic, so I can still run this here. I cannot have a public function. I can have a public function in there, just not it's not useful in the grand scheme of things. So I can go FMT. So I'll then call panic here. So I'll just call panic. This is panic. It's not a macro, so I'll take that out. So something funny would happen here. Let me run this code first, right? So run cargo run. Let's see what happens. Um, so this guy never returns; he runs forever, right? Run with Rust backtrace. Environmental variable is to display backtrace, blah blah. Blah. The main thread main panicked at and function blah 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 line 1 3 something, right? Panicked here, right? So like I said, the diverging functions are useful for situations like infinite loops or to terminate a program, right? So the exclamation mark type you know, can be cast to any other type, which is versatile in certain scenarios like match expressions and all. But that's like a completely different conversation altogether. But basically, like I said, you use this to panic a program, right? So another thing again to notice, if I, for instance, if I try to print this guy after the panic function has been called, I'll get an error. Get an error when I run this, or this line of code should not run. Some will not run, basically. So it says unreachable statement, right? Unreachable because we've panicked here. We've already exited from the program here, right? We exited from the program here. So if I run it, we still get that message. If I go run, and let me see. So this guy will run forever, right? So we just panicked and got out of the program, and this particular line, in fact, the error, the warning is there, right? If we even go up, we'll see probably see like a warning error for that. That we will not even get to that part of the code, right? So yeah, guys, I say guys. That's basically it. We've covered functions, closures, capturing, like capturing enclosures. We also looked at higher order functions and even diverging functions, even if we didn't really go in depth, like really in depth into it. So I hope this was helpful. If you have any questions, please consider dropping them in the chat, and I will do my best to answer them. And don't forget to like, subscribe, and hit the bell icon. It's the best you could do for me, guys. Please, right? It doesn't take anything to share this video with someone, right? And also, I need like your very constructive criticism to how I do my live streams. I would like to improve, right, over time. So until that, I'll see you next time. Peace. Bye.